You're all set, Ashley, to go live.
All right, awesome. So we are live, right?
Yeah.
All right, awesome. Cool. How's everyone doing today? There's been a lot of great talks that I've been able to follow along. And just want to give a huge thank you for the organizers of JS Friends for helping put this along. I know with COVID, things have been difficult. A lot of plans have changed, but it's really awesome to still be able to meet as a community and share a lot of this kind of like knowledge and learn from each other. So, without further ado, today we're going to be talking about GraphQL observability and kind of going through following along some of the thought journey that I've done over the past couple, maybe past year or so almost into this. So, first and foremost, my name is Ashley Narcisse. I'm an engineer. I work at Ultimate Company in Miami called Ultimate Software. You can guys can reach me at Twitter at underscore darkfader. There's a little bit of typo on the presentation, but it's DARKFADR. I'm super open, so please hit in my DMs or with any feedback or questions that you may have with questions that you might have about from the presentation. So today, what we're going to get into is a little bit of a maybe a refresher on GraphQL, and then kind of like solidify maybe our vision or understanding of what observability really means, and then circle back to GraphQL and how we apply that into GraphQL. So I have a confession to make. I guess not really much of a confession, but like I absolutely love GraphQL. Been using like heavily for the past 2.5, almost 3 years, in almost everything that I've done. And just the sheer joy from leveraging the system, right? Just the developer experience has just really contributed to all my like not just the hype, but like really like, my passion for it. And it's not just me myself, right? We can see the interest over time that the community also has really taken a liking to GraphQL and taken a lot of interest. And here is a graph over the past 5 years on just how much it's kind of like grown and generating some buzz, right, in the community. Um, the good thing is there's a lot of like high level big players that have decided to invest in the technology, which gives a really really good outlook for the near future, right, on the growth, continued growth and evolution of the technology. So GraphQL hopefully is here to stay for the time being until we find another until it evolves to the next abstraction and from where we go for. But it's been great having a lot of investment so that us as part of the community, we can not just take advantage of it, but we can continue to incorporate this into our much larger projects. So if this is your first time hearing about GraphQL or really getting an opportunity to kind of like dive into it, hopefully your expression isn't like just what. Hopefully you've had the opportunity to really like kind of explore what it is about. But if you haven't, we're going to take a quick little tour to kind of help with that, right? So we want everyone to start on the same page of understanding when we're talking about is GraphQL. We don't want anyone to be confused or left behind. So first and foremost, on the left is the logo and of what GraphQL is. And to start off, it's a specification, right? A set of rules that dictates how the runtime environment for the query layer of GraphQL should behave. And we want to dive into our second really key point is that GraphQL is it's a query language, right? It's a really good abstraction that allows us to describe the data that we would like to obtain and request from our backend services without being too opinionated on how that data is actually provided. So it kind of like floats at a very interesting layer. And second of all is that it's not a database. when we hear GraphQL, we think of like maybe graph databases or so, or a lot of the recent releases like Neo4j, recent-ish. But no, it's not a database. It's essentially like a thin layer on top that sits on top of your kind of like your API, right, in your existing systems to help better consolidate all those domains. And that leads into my next point, is that it really complements REST, right? It's not here to replace HTTP or say, oh, REST is deprecated. It works really well with it. And it's just something else that you can incorporate as part of your tool set to better solidify your domain. So let's actually dive into it. This is our example use case that we're going to be beating into and working through. So first is kind of understanding what it is. Yeah, it's just a user type and the user preferences. I'm pretty sure a lot of the services out there, we always deal with something about users. So it was a pretty good and straightforward use case to start off with. The first thing that you kind of would encounter when you're, building GraphQL services is defining the schema, right? And this is where we essentially codify, right? Like, hey, our domain abstractions, right? So we know that we're dealing with using or in our user preferences, things that we traditionally would have probably, have in routes or routes that already exist. We can describe that as into these types. In GraphQL ships with a few primitive types, as we're seeing, right? The ID, the string, and a Boolean. And we can create additional types on top of that. This is not JSON or TypeScript, although it looks a lot similar. And this really helps a lot with dealing with the learning curve, right? And getting on board to leveraging systems that you're building with GraphQL, right? Because there's a lot of existing knowledge that you're able to repackage and put together. So let's kind of like expand on this. So right here we have our user and kind of like preferences domain kind of like established, right? And we've defined this. But as a client and user, right, if your GraphQL schema just publishes this, I can't leverage this yet. So in order for me to leverage it, these types need to be exposed in a sort of manner. But before we go into that, if you notice that the user actually has a preferences, right, and the preferences, it has a devices array, a collection of devices that it keeps track of, right? If you kind of like map out this relationship, you see that a graph really starts to take shape. And this is really where GraphQL gets its graph in the name, right? So it's a graph of your domain model. And then it's a query language for that domain model for you to essentially add query, and you take those values that you can then leverage in your applications. And that's fundamentally what GraphQL really empowers, right? And provides and empowers you as a developer to provide to your end users, as well as leverage on your teams. Cool. So let's go back to now, how do we provide this data, right? There's two kind of root types that we want to keep track of, and those are the query and mutation types, respectively, used for gaining and obtaining data from retrieving data, and the mutation for manipulating data and other aspects, right? Whether it's creating or etc. Any form of mutations, those type of queries will be defined inside a mutation, and the same thing for a query. So we see here that on line 13, we are defining that we want a user's property, right, as a way of describing a user can or a client can request for a set of users that will then return them a collection, right, where each item in that collection adheres to the user contract or type that we've previously defined, or as illustrated up top. For illustration purposes, there's also a way we could pass arguments, in which case we're using this example on line 14 to retrieve a particular record based off their ID. That is, we're also specifying that the data that is returned from this query should adhere to the user type. Now we've, at this point, define just the model, right? And kind of like how that information could get, what they are the access points for the data that the model provides, right? Where do we talk about the implementation? How do we actually get that user's information from, right? Does it automatically do a database query, or does it know these things automatically? Well, with GraphQL, it provides mechanisms for you to implement, right? Exactly how to provision or provide that data. And let's get a glimpse right now. So there are essentially there is just functions that we're passing over, right? And these functions have a very particular signature, right? They take four arguments, which is the object of the data, that contains the data of the parent type, the arguments, that object that it has any arguments that are getting passed in. So like we saw previously in the user query. And we also have context for the entire application context. This can contain authentication and a few other application specific things to be aware of, as well as additional information that might get populated from GraphQL middlewares. So let's dive right into exactly how this data kind of works, right? So first we have on line 5 our function where we import our user model from our DBORM, and essentially we do a find all query where the ORM will build out the query for whatever data store that the data is located in, and it will return that in the resolvers. And that right there is kind of like a good stopping point for the users, right? Now we're going to get into what happens with that data. In the next layer, we see an example on line 9 what it looks like when you pass an argument to that parameter or that query parameter that we defined in our schema, right? So we're passing an ID, we're able to retrieve the ID from the args object. And with that args object, we construct a URL path to make requests subsequently to an arbitrary endpoint. Now we can squint real hard and think that, hey, this is like some maybe independent identity provider, right? That will give us that user information. We're going to do some very straightforward error checking, right? We'll log if there's any errors that occur. We turn null and simply output the user. Great. So now we've, from that query, we've hydrated the data for it. But if we take a quick peek, right, we're returning, say, either a collection of user or a actual user, right? So we still, GraphQL still needs a way of knowing how to take that raw data that we provided it and to correctly map that into the types, right, based off the user type that we defined. And the way that we go about doing so is exactly the same way that we've done for the resolvers that provides that information, right? So now we're going inside of a file that defines all the attributes for that user type. And here are all the resolvers, right, that handles the mapping, to say the least, right, for all the properties of that user that we have defined in our schema as with the type signature. So let's go right in. You'll see here that since our parent type, right, that we made a query contains data, it will get passed in now as the first argument. So before we had marked like variables just underscore object because nothing was getting passed, but in this case we actually have a user object. So we're going to name it as a user variable just for readability, right? And the same signature as the resolvers, the arguments, the context, and the information. For simplicity's sake, we're just gonna map out the user.id from that incoming object to the, and we're gonna continue doing so on and so forth, right? If we encounter a scenario where now this data is coming from a legacy database where the user column name for maybe, let's say maybe email might have a very verbose or DB specific naming convention, right? We can still map that data, the appropriate or that's coming from that database into the email property of the user. So now we're no longer bleeding out DB implementation based off the structure of the table, right? So now we have a bit more flexibility on how our backend implementation or wherever this data is coming from, right? And kind of create a separation and just perform the mapping between the properties. And last but not least, in the preferences, actually, we perform an additional API call since we know where we're going to get that preferences data because the user data doesn't have that already included. We're going to make an additional call and it's going to provide that data into the preferences. Now, before I continue, I did kind of like put a little trick question in there, and a little gotcha in there. On line 8, you'll notice that I also created the full name. We didn't define that in our GraphQL type, right? So even though the full name is retrieving the first name, last name, concatenating them into with some string interpolation to create a full name, unless I actually add that property into the type, the end users won't have access yet to really start to take advantage of that new field, to say the least. So whenever we're ready, we just need to actually make this feature available, we can simply go back to the type and insert that value. And a little bit of that flexibility really shows a little bit of power behind GraphQL, because if you can imagine teams that are working together, right? You have maybe a front end and back end team, and this is an example that's brought up quite often, right? They can pair up and agree on what that contract for each domain will be ahead of time before they get any like real feature work done, right? They've probably just done some basic setup and agree on a schema, and essentially anyone can go and use a package like Faker, right, to generate fake data for user avatar, user first name, so that now client teams are able to query the GraphQL API with the actual, based on an agreed upon schema, and build their features off of the UI, the fake data. And once the backend teams actually have the implementation completed, they can hop swap it. And because they adhere to the contract, right, it's a smooth transition. Now, yes, this is very much an optimal situation. There are other things that happen in the real world or in production teams, but more often than not, that happens so frequently that we forget about like just how smooth of an experience it's been. Having switched different technologies and platform in my day-to-day job, I oftentimes get how to say taken aback, right? Whenever I encountered those scenarios where I was like, man, like the experience from GraphQL is really, really awesome. And now we have to do it the old school way and just kind of like, power through it, which is not impossible, but it leaves a lasting impression on you. So Yes. So now let's look a little bit about what that query would look like. We're not going to focus too much on like exact libraries or frameworks to use, but kind of like stick to like kind of like at the very, very low level when you're performing like a querying for the data, in this case, where we have a wonderful website where we want to showcase all the beautiful people that have been attending, right, and that have also helped make JSConf a thing and just display it on a page. And we have that data somewhere. Anywhere, it could be anywhere, it could be a flat file, but we have that data somewhere. And essentially we could leverage, this query language, right? This query syntax and this exact query to fetch those users, right? And just those fields that we need in order to just build out our front-end implementation. We don't need to care about preferences. It has absolutely nothing to do with showcasing awesome people. We just want to see showcase their name and their avatar and maybe even their social if that data is even available, right? But you can see kind of like the mapping on how this is what you request or send over to GraphQL and how that data will come back to you as an end user. So this has been great. Hopefully I've gotten you guys excited, all right, on GraphQL and a little bit less scared now to maybe play with it or dive in. But once you do start to get the ball rolling, catch a good stride and developing your features within it, one impression that I did have, right, was it felt a little bit like a black box at times. Right, it was hard to understand really what was happening into my system, and that really like one question I kept on asking was like, well, like how do I know if everything's okay or if things go wrong? Like I could probably put a few things in place, and we're gonna go into I guess like the set of steps that we've gone through to tackle that. But yeah, this is kind of a pretty good big questions because there's a lot of great resources, videos, tutorials, books on building and properly structuring your schema for your GraphQL services. But there's far a bit less resources out there or in content around like the day-to operations, right? Once you've gone through everything, you've built your features and it's out in production and it's working, right? What does that look like? What does maintaining and keeping a GraphQL system up and running in production actually look like? So I particularly wanted to focus on observability because that is probably that's where everything should start, especially if things do go wrong in production. We need to figure out what actually did go wrong. So let's go on with a little bit of definition for it. And we can define observability as a measure of how well we can understand a system from the work that it's performing, as opposed to is leave it there. So it's kind of like I guess dive right into like how we can break that apart. We need to understand what's happening inside the system. To put it plainly, we are supporting the systems, right? So if things go wrong, that's how we're able to move rapidly to rectify the issues. So we can think of, all right, cool, putting monitoring. But monitoring is slightly different from observability. And I kind of wanted to highlight that dichotomy. Now, not to say that monitoring is bad. Monitoring is definitely good, and we should definitely have those things in place. But it just kind of want to showcase a few things that are different, right? So monitoring is, like, as I mentioned, right, is a bit more of a passive task, right? You're not actively observing this. You probably have some KPIs in place that you have systems that would alert if things exceed or go below a certain threshold, right? And a lot of things that you're doing, right, when it's troubleshooting or just keeping track of everything's good, is via a dashboard. So like you're heavily dashboard based. Think Elk dashboards, Kibana dashboards, and those things. Splunk, Datadog, a dashboard is everything, right? Not to say that this is bad or dashboards are bad, but that is kind of like the de facto way of how you operate when you're trying to figure things out when monitoring kicks off that something's wrong. And oftentimes it's you're dealing with static environments, right? And it's really monitoring has been the current state of monitoring, you could say, right, has been it evolved a bit, but primarily it still focuses on like static environments, right, that are spun up and that don't really change too much, or maybe has a certain level of stability in terms of like the feature level, right? But underlying infrastructure or whatnot and things that we're tracking on it, they're fairly static, right? Because we have logs and things that we put in place, and yeah, and those don't change or aren't dynamic enough, right, for us to really have any concern with that. So let's over into observability. And one of the things is that contrary to monitoring, right, observability allows you to be a little bit more active in how you analyze the state of your system, because you're driven primarily on hypotheses, and there's questions that you're asking, and you're pulling up traces and detailed insights from the instrumentation that you put into your system, right, to confirm, right, or or deny whatever assumptions that you make. And it's also like kind of like set up for dealing with like extremely dynamic environments. We could think of like the whole cattle versus sheep, right? The whole distributed and microservices, and being able to track a request across all the different systems that it touch. The toolings that kind of like fall under like observability, not to say that monitoring doesn't, but when you think of primarily tracing, which really gives you the observability of a system and how well it's performing, really helps you in those environments. So I guess we could talk about a few other things that goes into observability. We talk about metrics, and I actually like to classify metrics as those known knowns. So those are the things that we know that we know to know. This sounds funny, but and one of my favorite terms though. But yeah, with metrics, we know the key performance indicators, right, of how the system should work and behave at certain points, right? So you can think of, let's say, a request throughput, or CPU usage. What else? Disk space. Right, these are things that are pretty well known, and like we don't have to worry too much about getting caught off guard from that space, right? As long as we put the correct set of monitorings on there. To go along with the metrics, right, we put logs in our systems to help surface things that can go wrong, right? So oftentimes we want to be we want to guard on when we're coding, or defensive programming, to say for a better term. And when you're doing try catches, you want to make sure you're catching your exceptions. You're actually logging that out to at a certain point, right? Handling those exceptions appropriately. And there are other areas where the app can fail, right? And then you're saying, well, depending on certain scenarios, right, you write code to handle those cases. And those are your known unknowns. So like something unexpected might occur, but you know to account for those. So you actually have you're putting the mechanisms in place to capture those unexpected, but those unexpected things that you have the foresight to actually account for. And then here's where we go into tracing. And this is where we get a lot closer to really getting like a system in place, right, into our applications that helps us account for those unknown unknowns, like the things that we would like don't even think about or couldn't even like think, oh yeah, or like even like predicted would have occurred, right? And so the data that it helps that we get from tracing helps to surface those, and essentially we can narrow down our investigations, right? And focus on the areas that need to be rectified, but it's better formatted as opposed to maybe like some area that was failing due to some, let's say, some ridiculous edge case where some race condition was happening and there weren't any logs put in place, right? So at that point, right, that's an issue that's just entirely dark from like observability perspective, right? We have no idea unless we like actually debug and run the code on our machines, maybe with some production configuration. So those are some, like, I guess you could think like of the three pillars that help to really work together to really like give us the complete picture of observability, right? Because each of them by themselves doesn't necessarily, I would say, solve that question. So what about HTTP monitoring? That is also a very good question that some of you might have. You probably set up a health check on your GraphQL service, and that will publish out any insights on how well the system is performing. However, the thing with GraphQL is that it's essentially just one endpoint. You can configure what that endpoint will be. Some people have it as /API. Some people have that /GraphQL on top right after their base domain. And yeah, so if you put HTTP monitoring, right, you're getting GraphQL queries, right, which is that payloads into like that we saw where and that can vary depending on what particular feature or business case can occur, but it's still being hit by the same endpoint, right? So you're not seeing much deviation across the different use cases. So it's just one endpoint that you're only getting stats from. And so it's like, how do you know when things are supposed to be functioning fast, or if it's just like, yeah, this is a query that fetches a lot of data. So at this instance, in those scenarios, the API might be, instead of functioning in tens of milliseconds, it might actually respond in the hundreds of milliseconds. So maybe doing some alerting on that isn't exactly effective for the GraphQL well. So let's whip out our good old console.log. We're all senior devs here. Doesn't matter how long you've been here, and essentially console.log is my good best friend for not just troubleshooting, but also helping understand the system. So let's actually take our previous example and actually go ahead and start adding some logs so you can audit what the system is doing, or at least when it's running in production. So it's perfect. Here we are ignoring the users. We're just going to focus on the user query where we get the ID argument. And yeah, we're right at the beginning. We're saying, hey, here's the argument that we're receiving right there. That gives us a point where we can identify if the argument was even passed or not. And we are go ahead and performing the request. Once we get a result back from the request, we do some failure checks to see if the result is actually contains a value. If not, then we'll we kind of like log out, say, hey, this particular identifier didn't return back any results, and we're just going to return null. And if everything happened as we expected it to, right, so which is where it returned back a user, we're going to actually give a confirmation, like kind of like a confirmation audit, right? Say, hey, all right, cool, we found the user for the record, and we're going to return that to the user. We may or may not post a payload, right? Depends on the type of information that it contains, and if it's even useful for debugging. But now we can think that now when my request GraphQL queries execute, I will see this log, right? So if I query for ID 1, which corresponds to me, I'll see the logs that it's attempting to fetch my record based on the ID, and then it found a record for me And if we did so for 3, we would find that it would be undefined because we'll only have 2 people on our database, for example. Now, since this is a kind of like a very small case, but there's nothing that says we can't query for multiple users at a time. So let's say we know the IDs for 15 folks that we would like to highlight and pull their information from. And since GraphQL executes all of its lambdas in super magical order, and it's all asynchronous, right? It's not exactly synchronous. Well, it is absolutely not synchronous. Then we encountered a interesting scenario, right, where our log messages are happening in all sorts of orders, right? If we're fetching just one record, no problem. When we start getting across to the point where we're requesting multiple records, then it becomes to the point where we're not getting much context along with the log, right, for it to really be helpful. Maybe one thing we could probably do is like a tracing ID or maybe like a request ID. But still, the fact that it comes in different orders, it just makes it a lot painful. I don't know if you've experienced having to go through machines and read through machine logs to figure out what went wrong. This was a step, so at least we have that there, but it's definitely not ideal. So how do we move forward from there? Well, maybe one thing we could do is kind of like create a sort of retraction function, right? That first of all, at least tracks the execution times and kind of like tags the requests with some helpers, so at least we can get better markers. And kind of like that function is sort of like a resolver factory where we pass a set of resolvers and then it puts in this implementation. And we can expand on this, but just for demonstration purposes, we're just going to keep it very light and just say we want to add some timing. We're still going to encounter the issue where things are coming in on all sorts of orders because of asynchronous, the nature of GraphQL. But we still have, at least we're able to now improve our insights and get at least the execution times. So now if a request to a user takes 10 seconds, we could be like, whoa, why is that happening? So that's more information that we've obtained that we didn't have before. So another thing that I probably should go back. So this track function might actually, so for certain cases might seem fine for most folks, depending on how you use your queries, right? But in the case that you already had an pre-existing GraphQL instance and you want to add more, I use some better observability into it, right? It doesn't make much sense, right, to go back and add this track factory, right, around all your pre-existing promises. That's just quite a bit of toil, and that just, since you're so many areas that you're touching, as a matter of fact, every resolver is being touched. This causes just more rooms for human errors and potential for bugs to get introduced, even more bugs to get introduced, as opposed to just maybe some rather simple ones. So started to look into, hey, what else can I do to kind of like, with zero configuration, right? Not with zero manual work of needing to rewrite these resolvers, right? Get that same level of insight over again. So GraphQL gives us a set of like these decorator, I think they're delegates. I might be borrowing a term from the C# world, that we can add onto our attributes. So I was like, all right, this is perfect, right? Essentially, these delegates functions the same way as our track function, where it receives the resolver, and then we can perform action with the results on top of the result and before or after the result even gets, or the resolver gets executed. And then we can kind of transform it our own way and then return that final value in our way. So in our case, we just want to track the execution time of that resolver. So we can just, all right, cool, perfect, start, and now we're getting a good execution time for our requests. In the properties, out of all the types that we're requesting. So the good news is that we're no longer touching all of our resolvers and all of our, in all of our types. However, this change has now been moved over entirely into our schema file. So it's all in one file, which is fairly reasonable, right? But the problem now that I see that we've encountered is that the track function seems pretty straightforward, right? There's not much that we're gaining from it, other than it's just creating a lot of noise. So started to look beyond that and seeing, well, is there anything that we can use that rather than trying to build something ourselves? So we don't need to do all that code. So that works smarter, not harder. So Apollo, one of the frameworks that have a really good amount of good tooling, right? It's I'll say probably one of the most mature frameworks around building GraphQL services, because they've been doing it for quite some time. Actually has mechanisms to give you access to those metric data. And it's actually a flag, and they have a whole GraphQL engine, Apollo engine is what it's called, apologies, where they take that data and then they just ship it right over into Apollo engine themselves for you to even access. So perfect. I don't need to do any setup. I just need to set up a flag, which is setting tracking to true in my configuration file for my Apollo server. So this is extremely great. So I wanted to see what else does this provide me, and it seems like the traces and operations, or another one of the functionalities were kind of paywalled. So I'm like, no problem. I'll enable the free tier and give it a trial, on the trial period. And when I got to the traces, is really where I was like, oh man, this is it, guys. Mind blown. This is what we're looking for. Compared to all stuff that we were doing before, where like we don't even need to look at logs anymore unless like we're looking for a very specific set of information. This at a high level, like I can understand, or we can understand, right, exactly how the GraphQL resolver, or like the engine, right, or the runtime, executed all the resolvers and resolved all the users that it was fetching. This is a case of a query that I made, right, for a user type, and the users had also notifications, and it was resolving those notifications. You see, for the case maybe towards the middle, where it actually had found one notification, and we're fetching just the title of that notification. And we're able to see that drill down. It's like, oh, this is plenty. Now I kind of see a good picture of how my system is actually running. And this is this says tons. So I started to think, I was like, well, just leverage some of the Apollo GraphQL's tracing data that it provides as a spec, and it returns that to an end user, right? So Apollo engine is just really intercepting that and sending that to us. So I'm like, that's perfect. So we don't have to do any additional work. However, there's no really way for us to really extend that. And there's a few things that also kind of like caught me at a little bit unease. The free tier was kind of like pretty limited, which is absolutely no problem. Hey, if you give me valuable insights from my systems, I'm willing to pay for it, because that's just helping me solve my issues better. But one thing that was kind of particularly concerning was vendor lock-in. This is Apollo engine is for if you have to be using Apollo. If you're not using an Apollo server, this isn't really very compatible, especially if in language implementations that aren't in JavaScript. So there's a problem right there. So I wanted to look at a better way, or a more agnostic way of implementing it, regardless as if you were doing from JavaScript and you decide to transition to another language. And the main thing for that probably was like a little bit restricted for me was from the aspect of compliance and security restrictions, especially for those that might be working in different settings. So on-prem, right, or in highly regulated spaces, shipping your tracing data to Apollo Engine, a third-party service, might just be a straight-up no-no, especially if it's you guys have another approved system for tracing and observability throughout, whether it's Splunk, plus etc. tools. Yeah, shipping, adding Apollo engine might not be a viable option for you guys. So that might be a deal breaker for even being able to leverage on GraphQL in the first place, because you can't really maintain or get that valuable insights to keep the system up. So I wanted to find a better way around. The tracing actually reminded me, hey, in the SRE world, they have OpenTracing, which is a project coming out of the CNCF, which has been renamed to OpenTelemetry. And similar to GraphQL, OpenTelemetry is a spec. And so it's a collection of frameworks and libraries, right, that adhere to that API specification. And its sole purpose is for these tracing libraries and implementations and vendors, right, to make it vendor agnostic, essentially. So there's no more lock-in with a particular provider because your data are incompatible. Now, by leveraging OpenTelemetry, we can essentially say, hey, all right, dope, we can stitch it inside of our GraphQL resolvers and essentially go to Datadog, who has OpenTelemetry support, or Honeycomb, who also has OpenTelemetry support. There are other systems, I think Lightstep also, and a few out there. So that now gives you the capabilities to jump from service to service, depending on your particular needs, while still retaining that value, right, of what this that insight provides. So, well, OpenTracing, if you're going about it yourself, right, if you have the resources in place, you might potentially be using something like Jaeger UI to visualize that data. And you would also need the infrastructure in place to collect and store those tracing information from your GraphQL services. Now, this might not be too valuable, depending, especially if you're like maybe in the startup world, or you have limited funds for expenditures or resources, or maybe just from talent resources or time. Maybe a better approach might be just going to a provider. And so I started looking at NPM, which is kind of like our kind of JavaScript oracle, to say, hey, are there other awesome folks that have worked similarly on this particular problem, and how can it help us address this scenario? And as a matter of fact, there were. So the first one was Apollo OpenTracing, and the other one was Honeycomb Apollo, which actually helps us solve both answers. So the first is Apollo tracing, right? This one helps us implement OpenTracing into your GraphQL server with your own tracer. So if you have some sort of a library that initializes what that tracer is, because they adhere to that specification, right? That interface is being reused within the extension. So you can pick and choose and leverage and reuse those tracers inside of your Apollo server. So this was great if you have your own instance, or maybe there's even another provider that you just decided to stitch into here. And for our particular case, projects that I like to use Honeycomb. It was a really, really, really great product. And they have recently, as of, I believe, last month or 2 months ago, Honeycomb Apollo, one of the members of the community, managed to get it working with Apollo and published this repository. And I was ecstatic because I didn't want to have to set up my own internal tracing infrastructure. So I could just say, hey, we could just keep using Honeycomb and actually get all of our Apollo data into Honeycomb in addition to our additional services. So what does this actually look like once it's in? So once we kind of like just give you a little feedback, takeaway from what we got. Once we finally got Apollo, Honeycomb working, this is a screenshot taken from Honeycomb. You can see here that we're grabbing our orders, and we're also executing compute match, right? Compute match and get block, these are other functions, the sub functions that are inside of the resolvers. So we're able to now trace at a much better resolution, right? What's happening into our system. We did kind of flag it because when we had certain things on, it was like outputting well over 400, 500, almost 1,000 spans. And the span are each bar, right? It's each discrete operation. And the collection of these spans nested right, is what creates a trace. So this was great. And I'm like, all right, cool. This is valuable insight. We're starting to understand how our system is running. This is great. And we started encountering an issue maybe like a few weeks after. And we're able to consult the trace and see, hey, what exactly is causing some of the performances? Where are the things lagging? And we can see here, based on this query, that our viewer balance was actually taking like 6 seconds to resolve. And the alone ones, and this 6 seconds was probably like on the lower end, right? This was an exponential problem because it was 6, 15, 30. We got up to like 92 seconds for it to resolve, and like this is a problem. And this helped us pinpoint and identify the flaw that was causing the search delay, and we're able to bring those requests down. So to bring this into a close, I've thrown quite a bit of lot at you guys. We've gone over GraphQL, all right? We've talked a little bit about observability and kind of like the different pillars, right, that get thrown around of what observability really is. And we've kind of like gone a step by step and showing you the evolution of how you improve like that the quality of that insight that you're able to retrieve from your system, and finally are able to actually see how our GraphQL services are resolving our queries to give us the right amount of insight to better support our systems in production and be 100% confident that things are functioning as they should. So I leave this note for you. If you are interested in leveraging GraphQL or have been using GraphQL, do research into, or do look into leveraging OpenTelemetry and a form of provider to help bring that insight into your systems. And without further ado, that's it for my talk. Thank you so much, everyone. Please feel free to reach out to me on Twitter. That's my handle on the bottom right corner. And I'll be answering any questions in the YouTube chat. Thank you.
Thank you, Ashley.